horizontal asymptotes. So I'd like for you to take out Desmos, or you can use your TI-84 if you want. And I'm going to give you some graphs, and you tell me what the if there's vertical or horizontal asymptotes, and you tell me where they are. So I'm going to go to Desmos, and I'm going to start plugging these in, but I want you to do it as well. So let's do the first one. I'll do all three of them, but in different colors. So if you look at the first one, if you graph the first one, what do you see as far as any asymptotes?
Asymptote at -1, x equals -1.
So, right. So to what kind of asymptote is that? It's a vertical asymptote. So the equation is going to be what?
X equals -1.
X equals something for a vertical asymptote. So x equals -1. And I'm gonna make this red, and I'm gonna make it a dotted line. Yeah, and you can see that as x approaches -1, you get a vertical asymptote. Right. Does it have any other asymptotes?
Yes.
Where, Ella?
Y equals 2.
At y equals 2, and I'm also going to make this red. And make it a dotted line. Right, y equals 2. Yep, good job. So I'm gonna turn off the red ones. Matt, can you help me out with g of x?
Y equals 0.
So let's see the line at y equals 0. And that's what kind of asymptote is that?
Horizontal.
Horizontal asymptote. What about vertical asymptotes?
None.
There's none.
Oh my god, I got it right.
You sure did.
And there's no holes.
No. Oh, Desmos doesn't really graph that. So.
Yeah, but still.
So Desmos does not tell you where there's holes, and TI-84 does not tell you where there's holes.
But you also know that there's no holes because there could only possibly be a hole, even if there was one, at I in negative I.
Right, so that doesn't count. Right, complex holes or imaginary holes don't count. All right, so Cormac, can you help me out with h of x?
Yeah. So for the horizontal, it's going to be y equals 0 again, right?
So I'll turn that one back on. Yeah.
Yeah. And then still no vertical? Is it? Oh, no. There is a vertical. Which will be it's like 1. Yeah.
So let's try y equals 1, x equals 1. I should have let you tell me that.
Yeah. And then I don't think it like
What?
yeah, that's about right.
Yeah.
Yeah.
Looks like as x is approaching 1, then the graph is going to infinity on both sides. Yep. All right, close your devices, go back to notes. If we were to just look at these, close laptops. If we were just to look at these functions, could we kind of figure out where the asymptotes were?
Yeah.
Like, what can you notice about these graphs? Not the graphs. What can you notice about the formulas that tell you where the asymptotes are? Yeah, Finn.
For the vertical asymptotes, you can tell where they are based off of the lower part.
The
You
what?
factor the denominator.
Okay.
And in each place where and remove any just the thing that's just like 4. That's one. If one of the factors doesn't have x, you can just ignore it. But you do the 0 thing where you make every part equal to 0, and each of those is a vertical line at that x value. That's an asymptote.
So we're gonna have vertical asymptotes at the zeros of the denominator.
Yes.
So wherever this equals 0,
-1.
so we had x equals -1 as a vertical asymptote. And what about this one?
I negative I.
Right. So this is no vertical asymptote. And what about this one?
X equals 1. It is the vertical asymptote.
Right. So I could take the square root of both sides. Or I could, I don't have to solve it that way. I could say x minus 1 and x minus 1 and split it up. So that's x equals 1 and x equals 1. By the way, what is happening here?
Multiplicity.
Oh, that's called multiplicity. What does that mean?
So like how many times it appear?
It appears 2 times. It's multiplicity 2. Yep. Good job remembering weird math jargon. So we kind of have a rule now. So for vertical asymptotes, it's wherever the denominator has a 0. Good job. Can we come up with a rule for horizontal asymptotes?
Wait, so does h of x not have a vertical asymptote?
So
It has.
It has.
that was the last graph that we did, where it both left and right of 1, it was going toward infinity. So that was the vertical asymptote. It has multiplicity 2 on the graph. You don't see that really, but you can see it algebraically.
Of a theory for where you get the horizontal.
All right, what you got?
The what's the one I'm looking for? Well, the number in front of the x value in the numerator.
Coefficient.
The coefficient of the x value in the numerator. Because in f of x, there's a horizontal asymptote at y equals 2, and there's 2x there. And the other one, there's
Are we
y
talking about
equals
f?
0.
Are we talking about f?
Yeah, an f.
Okay, so let's look at f.
It has 2x in the numerator, and it has a horizontal asymptote at y equals 2. And in g of x and h of x, they have a horizontal asymptote at y equals 0, and they don't have an x value in the numerator.
That's some good guessing. It's not exactly right. Let me go ahead and give you the rule, and then you can see how it applies to the to the different graphs that we were looking at. So so here's the rule. So you already have. So if we say let f be the rational function. Tell me again what a rational function is.
A function that can be expressed as one function over another.
Right, so it's a polynomial over a polynomial. So in general, we could say some polynomial in the numerator and some polynomial in the denominator, if we want to use this notation. So capital N for the numerator polynomial, capital D for the denominator polynomial. And then I'm going to write a general polynomial. How do I write a general polynomial, Cormac?
It's the x. Wait, no, it's the ax, bx, cx, right?
I think you're thinking of.
Quadratic.
Oh, yeah.
So that's like the standard form for a quadratic equation. I want a general form for a polynomial, and I don't know how, like what the degree is for a general. So keep trying. Hold on. Go ahead, Cormac.
Isn't it just up n minus 1, up n minus 2?
So you're talking about the exponents?
Yeah.
So yes. So I have x to the n,
X to the n.
and then I have x to the n minus 1.
X to n minus 1.
But
plus
are
x
you
minus 1.
telling me that the coefficients on all of these is 1?
No, it's
Oh.
A.
No. Oh, ax n.
It's A. I'm not going to do A, B, C.
It's A1, then A2.
It's not A1.
It's A sub n.
It's
A
A
sub
N.
N minus 1.
And what is N?
It's not anything.
Nth degree.
Yeah, N is the degree.
It's the letter before O in the alphabet.
Plus minus a sub.
Plus, what's the next coefficient?
A sub n minus 1.
A sub n minus 1 plus dot 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 plus, and then you can pick it up wherever you want. You could say a sub 2 x to the what? Squared plus
A sub 1.
plus
A sub 0.
a sub 0, right. Right, that's like the general form for a polynomial of arbitrary degree. This could be a 16. This could be a 2. It can be any degree. And then I need different letters now to make a general form polynomial for the denominator. So let's use b now. B sub m.
Y to the m.
No, it's still x. It's a
Okay.
this. So the denominator is a function of x. So x to the
M.
m. So m is the what?
Degree of the denominator.
Degree of the denominator. And then b sub m minus 1, x to the m minus 1, plus dot dot dot, plus b2 x2 plus b1 x plus b0 or b naught. Right. And
B or not 2B.
and this is where d of x is not identically 0, so I can't just always have 0 in the denominator. What doesn't make sense. And n and d, can you guess? Have no.
B.
Can you guess? What are n and d not allowed to have?
Imaginary imaginary numbers or
Mm-mm.
irrational numbers?
Mm-mm.
We
The
should do hangman.
The same, the degree.
They can be the same degree. N can be greater than M.
Hangman.
N can be equal to M. N can be less than M. All those possibilities are fine. These are arbitrary. These are polynomials of arbitrary degree. They can match. One can be greater than the other. It's fine. That's all fine. Check, check, check.
Do I have an example?
Yeah, well, like,
Like you can't cancel them out?
yes,
Yeah.
that's a problem. So these rules don't work if they have any
Of the same.
of the same what?
Factors.
Factors. So I'm going to say where N and D have no common factors. If you get a polynomial that has common factors, what do you need to do?
Cancel them out.
Cancels.
Yes, you need to simplify first in order for these rules to work. So, all right, here's rule number 1. The graph of f has vertical asymptotes at the zeros of the denominator polynomial. So you can write that as d of x if you want to. So the graph has vertical asymptotes at the zeros, wherever the denominator has zeros. And that makes sense, right? Why does that graphically make sense?
So because it's like d of x is 0, it means like the whole denominator is undefined, and undefined is like the place where vertical asymptote exists.
Right. A zero for the denominator polynomial means that you're dividing by 0, so you're going to have a vertical asymptote there. Right. I'm going to say the graph has horizontal asymptotes depending on the degrees, and then I'm just going to remind it's n and m. So, I have 3 different cases. What are my three possibilities for comparing the degrees of the numerator and the denominator?
N is greater than M.
So let's do n is greater than m.
There's these rules.
But they kind of make sense.
Oh, yeah.
So can we did we have any polynomials where the degree was greater than the numerator? No, we didn't. So when n is greater than m,
The horizontal doesn't exist. Yeah.
maybe I should say there is no Okay, what's another case?
N is equal to M.
So what does that mean?
So the first, like the leading coefficient over the other leading coefficient is the horizontal axis.
So did we have an example of that where the degrees were the same in our F,
Yes.
G, and H?
F.
So Matt, how do the degrees compare in F? Hmm? What is F?
Graph function.
Oh, I meant, sorry, I didn't mean, yeah, I've been using F for both. I meant in these three functions.
Oh, 2 and 1.
What's the degree? What are M and N for F?
1 more.
Well, N is the degree of the numerator, right?
Mm-hmm.
And M is the degree of the denominator.
Yep. So what are they? What are those numbers? What's N equals what?
N equals M,
No. Oh, well, yeah.
or N is greater than M.
What is the degree of the numerator for F?
The top F, not the bottom F.
Oh, it's 1.
It's 1, and the degree of the denominator
1.
is 1, so they're equal.
Yeah.
So what happens when we have, like, what's our rule for
Oh, I get it. You're talking about the top function. Oh. Yeah.
what's the rule when we have the same degree on top and bottom?
There's has a horizontal asymptote
Where?
on the line
Which line?
F.
No. This is a continuation of that sentence.
Yeah.
Where's the horizontal asymptote?
On y equals a and then over b.
Right, in general, but in this case,
X equals negative 1. Wait, that's a vertical asymptote.
no. What is N and M here for this F?
1 and
1 and 1, so they're equal. So when they're equal, I have a horizontal asymptote. Where?
1. On the first one.
First what?
First line.
What's the
No.
first
Degree.
line?
No. No, look at this. This is my rule. This is my rule right here. In this case, when N equals M, this is going to give me my horizontal asymptote. What does this mean?
I don't know.
What is AN and BM?
The numerator and the denominator.
No, it's not the numerator and the denominator. Where do you say A sub N and B sub M on this?
It's the degrees.
It's not the degree.
It's like the first term.
This is the degree. Those are the degrees. It's like x to the 7th over x to the 5th. That's the degree. Where do you see A sub N and B sub M?
At the very beginning.
And what is that?
The leading.
Yes? Yes. And in this case, in the orange one, the tomato red one, what are the leading coefficients?
2x and x.
2x is not a leading coefficient. 2?
2 and x. And 1.
So what is my, don't say it, don't help him. Where is my horizontal asymptote?
2.
That is not the correct answer. I'm not gonna accept a
Horizontal asymptote equals 2.
no.
Y equals 2.
There you go.
Yo.
Yes.
That's just
No, who said that?
Me.
No. We're just learning this for the first time. Cormac, what's my last case?
M is bigger than n. There's no vertical asymptote.
So the last case is n is what?
Less than m.
Less than m.
No vertical asymptote.
Is that the rule?
Nope. It's not even close.
Oh. So, did we have any examples of where the degree of the numerator was smaller than the denominator?
G and H.
G and H, and where did they have horizontal asymptotes?
0.
At 0.
Oh.
Yes.
So then if n
So
is-
anytime the degree of the numerator is smaller than the degree of the denominator,
then
it's always going to be
horizontal asymptote is 0.
horizontal
Asymptote.
asymptote.
So everything has a vertical asymptote.
No.
Not many things. Wait, nothing. Sorry. My bad.
Where is the horizontal asymptote for n is less than m?
0. Is another.
Focusing on horizontal asymptote.
So every time you tell me an asymptote, you're going to give me an equation of a line.
Okay. Oh, at y equals.
Y equals 0. So you weren't wrong, but
Yeah.
it wasn't complete.
Okay.
So I want y equals 0 as the horizontal asymptote for the numerator having a smaller degree than the denominator. I want y equals the ratio of leading coefficients when the degrees are equal, and if the degree of the numerator is smaller than the degree of the denominator, larger, then you're going to tell me there's no horizontal asymptote. Yep.
Do some example for this.
Let's do some examples. Find all vertical and horizontal asymptotes for Can you just tell me? Can you just like read it off? Can you say
Yes.
can you say
Yes.
vert and horiz? Now, I don't want just one. I don't want one or two people to shout it out. I want you to write it down. But I'm gonna come around. time the leading coefficients come into play is when the degrees match. That's the only time.
Oh.
Did you check on?
So there's no vertical or
Check. Back.
I mean, there's none for either.
No, I just tripped over nothing at all.
Oh,
It was
I thought
all
you
me.
said something like that.
It was all me. No, I don't blame you.
You get none for everything.
I thought.
Did you write down the problem?
No.
Then write down the problem. This is for your notes.
Okay, I got you.
I got like none for vertical, but not for horizontal.
Well then, Mr. Shadle,
Mm.
if the leading coefficients don't match, does that mean there's no horizontal asymptote?
No,
Well, then how
that's
do I-
not what that means.
What's the degree?
Oh, if n is bigger.
What's
than-
N and what are N and M here?
Oh wait, wait,
Matt?
I get it.
What are N and M here?
Good, 2 and 3.
No.
No, the N and M, not the
Oh.
coefficients.
Oh, 1 and 2.
1 and 2. What are N and M here?
2 and 2.
Oh.
Oh, I was looking at leading coefficient.
Y equals 0.
Wait, I'm confused.
So am I. Don't worry, man.
So you should say,
Oh.
Just read your.
like when I'm asking you a question like this, unless it's multiple choice, when I'm asking you a question like this, you should say VA colon or vert
Yes.
and HA colon or H colon.
Yeah.
So you tell me what it is that you're reporting. Abbreviation is fine, but I would not just write down something and without saying what it is.
So when do we look at the leading coefficient? Why do we look at that?
Why?
Sure.
That's for when N is equal to M.
Yeah.
Finn.
Sure.
I mean, not be quiet. Chill.
Could you check my answers, Mr. Shadle?
When is the only time when we care about the leading coefficients at all?
N equals M.
Only when the degrees are the same, because the degrees, the leading coefficients do not come into any other case. Doesn't happen here, doesn't happen here, doesn't happen here. That's not correct.
So vertical is like x squared minus 1 equals 0.
Mhm.
So x squared equals 1
Mhm.
and x equals 1.
Mm-mm.
Mr. Shadle, is this correct? Okay.
You're correct all the way until this step. What numbers multiplied by themselves
Oh,
give you 1?
1 and x.
There you go. So you can't just kind of look at it and assume that it has none. So for vertical asymptotes, it's asking you to solve for zeros of the denominator.
Wait, were my horizontal ones right? Ln square root of 1. X equals square root of 1.
So what's the next one? Hmm?
Vertical?
Yeah.
Square root of
What's square root?
1. 1.
No.
No?
That was for G, right?
Yeah.
So everyone who wrote, so if you said horizontal, and vertical asymptote, you wrote x equals 1 because you said x squared minus 1 equals 0, x squared equals 1, x equals 1. Let's check. 2x squared over x squared minus 1. So let's check.
I think it's 3x squared minus 1?
Hmm?
Plus 1.
What's that?
Is it
Or like,
3x
x
squared plus
minus
1? Oh, minus 1.
What are you saying?
There's like a 3 in front of the x squared, I think. I'm
But
not.
that's a different one. Mr. Schultz's note, that's
Did I?
not
That's
correct.
is that not the is that not the one I gave you?
2x squared
I'm
over
doing
x
this one.
squared
Got
minus
it.
1.
I'm doing that one. I'm doing G. So, did I write down right?
Yep, that's correct.
So if you said x equals 1, and I'm going to make that a dotted line.
You're wrong.
You're only half right.
So were you right about x equals 1 being a vertical asymptote?
Yes.
Yes.
Yes, you were. And then what else did you say about the horizontal asymptote, by the way?
Y equals 1?
Y equals
2.
2.
Wow.
Boom.
Were you right about that one?
It also equals -1.
What are we missing?
Negative
The
1.
whole
-1.
Negative 1.
X equals -1.
Isn't it, let's see if I put in x equals -1.
Equals
Wait, no,
-1.
not x. What? Okay,
Is the x equals -1 a
Vertical
vertical asymptote?
Yes.
How did we miss that?
Oh, because it's the plus or minus 1. Yeah.
Because it's X.
Yeah, it literally is plus or minus. I mean, this is a graphical confirmation. If you've ever wondered why we look at x squared equals 1 and we say you have to say x equals plus or minus 1. X squared equals 1 or x squared minus 1 equals 0 gives us 2 vertical asymptotes. So don't forget.
That's true with all squared equations. There's going to be a positive and negative.
So if you have if you're taking an even root, right? It's not going to be the case for x cubed, but it will be the case for x to the 4th. So if you're taking an even root, you have to account for pluses and minuses. Because if you square -1, it's going to give you 0 in the denominator. Okay, so for the purposes of this example, I'm going to say find asymptotes.
Wait, what was the answer to A?
So what was the answer for A? Was the vertical asymptote was at 3x squared plus 1 equals 0. 3x squared equals -1. I can already tell that I'm going to have to resort to complex numbers to get an answer for x. So I'm going to say no, or
Yay.
if I write vert, I can just write none.
Yeah.
And horiz,
Y equals 0.
y equals 0 because
Oh my god, because the
In
n
other
is
words,
smaller
the
than
The
bigger
n is
the
smaller than
the
m.
big. The
Right.
lower is the bigger than the
Stop
big.
stealing
Up.
Right.
my trophy, man.
The lower is the bigger than the big up, though.
And did we finish over here? If we say plus or minus.
So if we were on a test, would you want x equals 1, comma negative 1, or x equals plus or minus 1?
Both are clear, but I do want you to say, I want you to say vert, or I want you to say vertical asymptote, so I know what you're telling me. So that part does matter. Otherwise, you can say x equals 1 comma minus 1, or you could say x equals plus or minus 1. Both are clear. You cannot say vert 1.
Vert 1.
You cannot. Or plus or minus. You can't say vert plus or minus. Because that's not an equation of a line.
Say E
A vertical asymptote, any asymptote is a line. All asymptotes are lines. So I want an equation for a line. That's why you have to say x equals here. You have to say y equals here if there is one.
You can only put in a singular number with no other context if you're working on a one-dimensional plane.
A single number?
Yeah.
No.
On a one-dimensional plane.
No.
Because then there's only one axis of movement, and you don't have to specify what axis you're talking about.
But when
because
are we
there's only
talking
one.
about a one-dimensional plane?
I'm just saying that that's the only case where you don't need to put x equals or y equals.
We probably will go higher dimensions. We probably will not go less.
Yeah, I'm just saying, like, that's not my point. I'm just saying, like,
Are you just mad because you don't have candy?
no.
Yes.
So for the purposes of this next example, I'm gonna ask this way: find asymptotes and holes. But this is the only time I'm gonna be this nice. This is the only time I'm gonna put you on notice that there is gonna be a hole as well, because
How do we know how to find this?
oh, let's find let's do it first, and then we'll talk about how we do it.
So about like multiplicity?
It's not. No, holes do not relate to multiplicity. Holes relate to what?
Numbers.
Holes relate to what?
Numbers.
Holes are generated how?
With pencils.
No,
Paper.
no. Joke answers don't count.
Aw.
Okay, so let's try it and then we'll talk about it.
Also, when a specific number results in an error in the function.
No,
Because asymptotes also do that.
yeah. So vertical asymptotes is when the denominator goes to 0 to make your equation blow up. Right. So
Oh, I know how the holes.
That's when the thing in the denominator will be equal to 0, so it wouldn't exist.
no,
It's
that's a vertical asymptote. So when the denominator has a 0, that causes the graph to go to 0. Or they could both go to positive or negative infinity, or mix them up. Yeah, Finn.
When the numerator and denominator share a factor, there is a hole at that 0.
There you go. So what are we doing when we're saying find asymptotes and holes? What am I being generous and warning you about ahead of time that is going to happen on this?
Factor.
There's going to be a common factor. But you always have to do this. So this is the only time I'm going to say find asymptotes and holes, because I could just say find asymptotes and give you a function that still needs to be simplified. Oh, that's so
Ooh, I know
mean.
where the hole is.
That's so tricky.
I know where the hole is,
It's at 6.
and I know where the asymptote.
Is it?
No.
Oh.
And I also know where
Is
the
it at 7?
asymptote is.
The asymptote is at positive 6.
Also no.
Wait, no, the whole is positive 6.
So
No.
you do it. You do it.
Ah.
I'm going to come around.
I don't know how to do it.
Yeah, that's fine.
By the way, you are safe looking at the degrees now. You're safe now looking at the degrees for the horizontal asymptotes. Meaning you can go directly to this for horizontal asymptotes. That's fine. You can do that. So if you want to answer hors now, you can. So what's the horizontal asymptote?
Why is it?
What?
Y equals 1.
Yeah, it's 1 over 1. So the leading coefficient's 1 here, 1 here. 1 over 1 gives you horizontal asymptote is 1. That's fine. But you still need to find vert and you still need to find holes. So we'll let you do that.
What What is
I
ear,
think I have the
El
answers.
Cinco?
What is what?
What is?
Oh.
El Cinco.
Photo.
What was it?
What is ear
Permiso
El
el
Cinco?
cinco.
Oh, permiso el cinco.
Permiso el cinco.
Please. Permiso el cinco.
No, you don't have
Permission to 5. Permission to 5.
No, I permit to buy.
El Cinco low-key sounds like a name for a bathroom.
It does, dude.
Dude, it's like saying permiso number 2, but it's just like El Cinco.
Permiso a dos, por favor.
What if we have number
But
1,
like-
number 2? What's number 5?
Well, number 3
That's
is
some,
probably
that's some
like
good calculating
all
right there,
of them
Ella.
doubled plus the
I did
curve.
this
That's some
before.
quality. Where did you do it?
about
8th
the same
grade.
time.
I have like a full section in my notebook. And
Yeah.
the
Ella does not. She's capping. She's
Please,
lying.
you,
So
look,
this-
you do long division to do the
So you just did it last year?
Yeah.
You're in 8th
When
grade.
did you take geometry?
Wait, you're in 9th grade?
Geometry, I never did that.
That would be number.
I did it
Smart.
over the summer,
I
but then I
freaking
did
did it.
not.
Smart.
It was awful.
I think nobody should take geometry.
I
Oh,
know,
no.
it sucked.
It was
Geometry is
so
awful.
What's number 3?
Which find out?
So vertical would be next to 2 and 1 visualization, so that and poles would be, would be next to 2 and.
Are there any
I'm not sure like.
Dude, Ellis was
poles
from
would
6th
also-
grade.
would also be.
Well, it's because I had take-apps.
No.
He was really bored with 8th grade.
No.
Do you remember
no,
hanging
no.
out with Ellis in CSS?
I have
Ellis?
the answer.
Yeah, no, I can't think of any
I
else.
remember that
Yeah.
child is.
Or is he now?
Oh yeah, well,
So is
Ellis.
Milo.
Yeah, Milo's coming.
Yeah, who else is here?
Genevieve.
I don't know who that is.
Oh, dude,
I
I knew
don't
a
know,
girl
she was
named
there, I
Genevieve
think.
when I was a kid.
Alright.
Where's else Ella?
Some other people.
Okay, red lights 4 equals 1. I was like,
Okay.
what?
Are they all 8th graders?
And they're all gonna come in, or, well, all the ones that I saw
Where
were
did you
freshmen, so we'll
simplify
come in.
this actually?
Let's simplify.
Oh, the 8th graders are gonna be
I need like
our 7th
eight
graders.
assistants.
Oh wait, that's not crazy for you.
Oh,
I'm
permiso, I have not a O because I'm more
Here's the
confused, so-
simplified
Permisos
version.
el cinco.
Here's the simplified version. Monsieur Shadle.
2I.
Okay, I need
Monsieur
help.
Shadle.
Yes.
Yo put
I have the
ayudar.
simplified version for you.
Wait, no. Yo necesito ayudar, por favor. Ayudar. No.
Permiso cinco.
You think that's Spanish as well, Nancy?
Yeah.
Permiso, El Cinco.
Yeah.
Yay. I'm so
There
right.
you go.
Guys,
X minus 1 over X minus 3.
guys, just listen to me from now on.
Can I? I got you, Finn.
Well,
Because I
Do
did
it then. What is?
Right?
so
doing a
so
record
what
test,
and what does
we
that
need to go
mean?
into
What does that
math.
mean as far as holes go?
The whole is that X
Think about
equals
it.
2. Or X equals 2.
So doing a what? More.
Our work, like the things they tell us to do.
X equals 2?
You just
It's
something.
x plus 2 gives you the hole.
Yeah. So
Oh, now
X
you
equals,
just-
X equals negative 2.
Right. Right.
So, X
Aren't I like
equals
very
2
smart? A smart cookie.
whole. Okay.
You're very
Now
special.
let's-
Thank you, Finn. I know that's what my
Same
old
way.
teachers used to say in my class.
Same way.
Big Randy.
X
Oh, I never knew his name.
Yeah.
You know my old school bus. Used to be-
Do it.
Oh.
Says let you cook.
Yeah.
I was trying to let you.
Okay.
What?
wait.
Me? Cook? Wait, I actually cooked.
Okay, so this whole list of rules, which you definitely should like get a compact version into your note card.
No Dobuco.
These things are true when the numerator and denominator have no common factors. That means you have to do what first before you apply any of these rules?
Find if they have compact.
Find if they have it, and then if they have them, what?
Remove that.
Remove them
And account for the whole.
and account for the whole. That is the entire list of what you have to do. All right, so what do I need to do with this? So I have this, and I need to do something with it. What do I need to do?
Blow it up. Kaboom.
Kablooey.
Wow.
Bam.
Kablooey.
I need to factor it. So how can I factor the numerator?
X plus 2, X minus 1.
Somebody else? How do I factor the denominator?
X plus 2, X minus.
Ooh, X. Oh.
X plus 2,
X minus 2.
x minus 3, because that gives me minus 6. And then plus 2 and minus 3 gives me negative x. Right, so that's the factored form, that's still f of x.
And then you can cross out x plus 2's on the top and bottom, and then you can find the whole, because x plus 2 gave you the whole, which means the whole is x equals -2. And then you have the vert, which is x equals 3.
You the smart cookie, Matt.
Thank you.
So for this one, do I have to say what x is not allowed to be equal to?
Absolutely not.
I don't have to do that. It's implied. So sorry. Let me take an extra step here, and I'm going to say this version is exactly the same. At this stage, do I have to say what x is not allowed to be equal to?
No.
No, it's all self-contained. At this stage,
-2.
when I have x minus 1 over x minus 3, do I have to say what x is not allowed to be equal to?
Oh, yeah, because you have the
X does not equal
-2.
-2.
X is not allowed to be equal to -2. Even though it appears in this version, it's fine. This is actually my whole. That's my whole.
Thank you.
If you want to report it as x equals -2 and then figure out what the y value is, that's also fine, but you don't really need it.
So whole is about like common factor in both denominator and numerator.
The whole is generated from common factors. So if I graph this, I'm not allowed to just say it looks like this. Basically, I have to account for the whole at x equals -2.
But the graph does look like that.
So that's my whole, and then all I need now is my
Vertical asymptote.
vert, and I can get that from my factored version. So what's my vert? X equals 3. What was my horiz?
Y equals 1.
Y equals 1, and my whole is x is not allowed to be equal to -2.
I feel like vertical asymptote should also include like x equals -2.
It's not a vertical asymptote. It's not a vertical asymptote. So I realize I'm going a little bit late. I apologize for that, but let me just graph this quickly to show you that there's no vertical asymptote. So x squared, my original version, x squared
-1
plus x
plus x.
minus 2 in the numerator, and
X
x
squared
squared
minus x
minus x minus 6. Is there a vertical asymptote?
Yes.
Yes.
3. That's
Right. Right.
Thank you.
Right. And what was your question, Jason?
Oh, I think because originally I think like x equals -2 would also be a vertical asymptote because. Like,
Yeah, so x equals -2. Yeah, sorry, I forgot what I got excited about and was trying to prove to you. Right. So here's my Desmos. So x equals -2. There's a hole, but the graphing utilities don't provide it. They don't show the hole, but is there a vertical asymptote there? No, the cancellation means there's no vertical asymptote there.
Oh, I see.
Yes, there is.
Vertical asymptote, let's look. X equals -2. Is that a vertical asymptote?
Not there. Not there. Okay, that's why. Okay, I thought you were referring to something.
He was wondering about because in this version it appears that there is
Miso
an,
el luncho.
look, he's saying that it appears that x equals -2 should be a problem, but it's not because it cancels.
For miso el luncho.
So we have web assignment homework.
Thank you, Mr.
Yes.
Hill. Have a great
Yes,
day.
you definitely have web assigned homework now
4.1.
on 4.1. We're done with 4.1.
Bye, Mr. Shield.
Bye, thank you.